this exercise is that we want to bring together our knowledge of how to find our asymptotes and focus a little bit more on the sketching part of it. So there's only 2 questions here, and says a menu, but it's a step, the steps to go through to help you sketch your graph. So there's a step 0. I don't know why they didn't just start at 1, but anyway, a step 0 is just to prepare the equation that you're given. I guess that's why, because it's just to make sure that your equation's in the right form before you get started. Okay, so first of all, preparation. Combine any fractions by using a common denominator, then factorize the top and the bottom as far as possible, okay, because that's going to help you find your zeros and your discontinuous points. Okay, so just make sure your equation's in the right form first. All right, but then this is actually how we get to the sketching part. First of all, we want to find the domain, possible x values. 2, we want to find out if our graph is symmetrical, that is the odd, even, or neither part. Part 3 is where a lot of work will happen in here. We want to find all the intercepts, so that's x-intercepts and y-intercepts, so that's found by the y-intercept is when x equals 0, and the x-intercept is when y equals 0. And we want to find the sign, which means we can use our table of signs to see where our graph is positive and where our graph is negative. Ben, do you mind just being quiet while I go through this, please? Next question, step 4, we want to find all of our asymptotes. So vertical asymptotes, which as a reminder is our discontinuous points, whatever makes our denominator of our fraction 0, that is where our vertical asymptotes are going to be. Our horizontal asymptotes are found by putting positive infinity and negative infinity into our equation. Okay, so here we go. Question 1. Sketch y is equal to 3x squared over x squared minus 4. No other guideline to go on, just wants me to sketch it. But if we work through our process, first of all, step 0 was to do our little bit of prep, which means I want to factorize everything as much as possible. The numerator cannot be factorized, but the denominator, I can do a difference of 2 squares. It would be x minus 2, x plus 2. Okay, so that's just my preparation stage. Now, starting with the real work, we want to find our domain. Okay, what are my possible x values? Because I prepped my equation, I can now see on my denominator some x values that would make it 0. So from that first bracket, the x minus 2, x cannot be equal to 2, or my denominator would be 0. And the second bracket, x could not be equal to negative 2. Either one of those values would give me a denominator of 0. Okay, so they're going to be where my asymptotes are, but we'll save that for later. Step 2 is to determine the symmetry. Okay, so symmetry is we sub in f of negative x and to determine whether it's odd or even or neither. Into my equation, I have 3, instead of x squared, it's going to be negative x squared over negative x squared minus 4. Now, anytime you square a negative number, it's going to become positive. So that is the same as 3x squared over x squared minus 4, because squaring those negatives just became positive again. Because what I now have there is exactly the same as my original function, I say that is equal to f of x, original function, and therefore that means that it is even. So my graph will have to be perfectly symmetrical over the y-axis. Okay, it's good to know. Step 3 is the intercepts. And signs. Okay, so the intercepts, if I start with when x is equal to 0, if I were to sub x is equal to 0 into that equation, I would get 0 over minus 4. This is my original equation, which would give me y equals 0. Okay, so the origin is going to be my x and my y-intercept. There is, or is there, I should probably ask you, looking at the top of the fraction, is there any other zeros that I could find? That would be if there was more things factorized across the top, any other brackets that would make the numerator 0. Unfortunately, there's only an x squared up there, so 0 is the only thing that's going to make the top a 0. So it is going to be the only one, but something to look at. So the only 0 is going to be at x equals 0, and that's by looking at my numerator. Okay, now we're going to use our table of signs to determine the sign part of this step. So let's go down here, cross here, x, y, and sign. So there is 3 x values that I should be mindful of. I have got a 0 at x equals 0, and I also have these 2 things from up here, my asymptotes, my discontinuous points. I haven't rewritten them again. You could rewrite them down here. So let's start with the smallest one, leave a gap. We're going to have -2, leave a gap, 0, leave a gap, 2, and then an extra 1 at the end. So down at -2, something less than -2? -3. Between 0 and -2, I think -1 and 1 and 3, right? They're the obvious choices. So at -2, we know that that's an asymptote. At +2, we know that that's an asymptote. And 0 is the 0. Okay, so we just have to fill in the in-between ones. So we get our calculator out, and it's time to start typing some stuff in. So I won't do all of them, but let's do the first one. We're going to type in, what was my equation? There it is. It was 3 times by bracket -3 bracket squared over, I'm just going to type in 9, save myself the trouble, 9 minus 4, because -3 squared is 9. Okay, so I get 27 over 5. It's positive. Okay, and you go and do the rest of them. The next one, assuming that I typed this in right before, I got -1, which is negative. For +1, I also got -1, negative. And at 3, I got 27 over 5 again, which is positive, which kind of seems fitting because we do know this graph is meant to be symmetrical. Okay, part 4, we now want to find our asymptotes. Hopefully we can squeeze that in here. Okay, so first of all, starting with the vertical, we already know that it's going to be at x equals plus and minus 2. There's two asymptotes. Okay, so if we were going to analyze as x is approaching positive 2 from the plus side and 2 from the negative side. And we're also going to have to do -2 from the plus side and -2 from the minus side. Okay, we can use our table of signs to help us with this, or you can type more stuff into your calculator if you prefer. So looking at the +2, which is over here, on the plus side of that, which is on this side, I have a positive value. So this is most likely going to be approaching infinity. Okay, so y is going to be approaching infinity there. If I go to the left of that asymptote, it is now negative, which means y is going to be approaching negative infinity. Okay, do the same thing for the -2. Look at the -2 down there, my asymptote. If I go to the positive side of it, it's negative, so that will be negative infinity. If I go to the left of it, the negative side, it's positive, so positive infinity. Okay, try and do it a little bit faster. Hopefully you stayed with me. All right, that's my vertical asymptotes. Horizontal asymptotes. we would want to divide by what power of x? Equation. It's an x squared on the bottom. So divide by x squared. And that's going to be y equals 3x squared divided by x squared is 3. X squared divided by x squared is 1. And then minus 4 divided by x squared. So as x is approaching infinity and negative infinity, that's how you find horizontal asymptotes. When I put infinity into plus or minus infinity really, into here, this becomes a 0, which means my y is approaching 3 over 1 or just 3 for both of them. Okay, it works for both of them. So y is approaching 3 for both. So that's a horizontal asymptote at y equals 3. Okay, that's all my information done. Let's put it on a graph. I put all mine on the left, so they had a little bit of space on the right.
How many marks?
A few. Like 4. 5, 4. Probably 4. No, probably 5 because of 4 steps. Okay. So, putting on the information. So as you can imagine, I can't give you too many of these on the test. They take too long. Alright, from the beginning, I have got vertical asymptotes at 2. So horizontal asymptote at x equals 2 and at negative 2. Oh yeah, thank you. Vertical asymptote. And negative 2. Thank you, Ben. No, I wasn't talking about that, but thanks. Then I have got, what else have I got on there? I've got intercept at 0, 0. So I'm looking through my list. I will look through symmetry, knowing it's even. Then looking at my intercepts, yeah, I'll get to that part. I have an intercept at 0, 0. My horizontal asymptote is at y equals 3. There it is. Okay, now using my little analysis down there in step 4. If I look at my vertical asymptote, when I am at the positive 2 asymptote, just on the right of it, bigger values, I'm at positive infinity, which means just to the right up here is way up high. Just to the left of that asymptote, I'm at negative infinity, which is way down here, just to the left. At negative 2, on the positive side, I'm at negative, on the plus side, sorry, I'm at negative infinity, which is down there. And on the negative side, I'm at plus infinity. My horizontal asymptote, they're both approaching 3. I didn't do the plus and minus signs. Ooh. We can probably guess which way they're going to go though. Because, let's have a look. If I have my intercept up here at 0, 0, it's going to come down through these ones down here. The part up the top, I can either go back and work out the plus signs on these ones down here, or if I'm up here, pretty good chance it's going to come around in there, isn't it? You could sub it in and check. If you sub in a really big number into your fraction, you'll probably find that that should have a plus sign there. And this one comes around like that. Okay? So both of those ones are approaching the 3 on the positive side. It's the only place they can really go. All right, next one. You can always check things with Desmos, but you do have to be able to sketch them without. One more, question 2.
Oh my.
Sketch f of x equals 1 over x plus 2 plus 1 over x minus 6.
What the heck?
So the first thing we do, which is not actually a step, is just to prep our equation so that we can read off any zeros and intercepts, which means I need to have one fraction and everything factorized. So f of x equals, my common denominator will be x plus 2, x minus 6. That means the first fraction I have to multiply by x minus 6, and the second fraction I had to multiply by x plus 2, and I pushed them together already. Makes things easier. Collecting up the top, I have got 2x and minus 4 over x plus 2, x minus 6. And then I can even factorize the top. Take the 2 out and have x minus 2. Okay, that tells you so much already. I can already read off that equation where I have 2 vertical asymptotes and 1 0 from the top. Okay, yes, language. Okay, so let's start. Step number 1, domain. Domain, looking at that denominator, I can have any value of x I like except for what makes my denominator 0, which is going to be when x equals a negative 2, so x cannot be equal to negative 2, and x cannot be equal to 6. Step 2, the symmetry. Sub in f of negative x and see what happens. Now, if we sub that into our factorized version, that will probably make things easier. So let's do 2 bracket negative x negative 2 over negative x plus 2 negative x negative 6. Now, on the top, I can take a minus out of that bracket, which will give me negative 2 bracket x plus 2. On the bottom, in order for them to be the same, I'm trying to see if I can get it back to the original equation. I could try and bring minus signs out of each of those brackets as well. So it would be negative x minus 2 times by negative x plus 6. Now the 2 minuses on the bottom will make a plus, but unfortunately it's still not back to the original equation. Okay, so it's not going to be even because it's not the same. If I were to take the minus sign out of the top to factorize that out, I would get minus, too many brackets in here, but that's just the way it is. But all that stuff inside the bracket is still not the same as the original function, so it's not odd either. It's going to be neither. It's not odd, it's not even, it's neither.
What did you pull out of the bottom? Nothing.
Nothing. You only have to take the minus sign out of the top. If you take it out of both of them, you actually haven't taken anything out.
Why? Because it reverses.
Because they cancel each other out.
Yeah.
Minus on the top, minus on the bottom just makes a plus. You haven't taken anything out. Okay, step 3. We now want to do our intercepts and sign. Okay, so we know from the top of our fraction, maybe I'll highlight it for you, this one here, this is my factorized version. The bottom gives me the discontinuous points, but the top gives me the zeros. Where do I have a 0? 0, whatever makes the numerator 0. 0 would be a plus 2. You would be making the x minus 2 equal to 0, which means that x is going to be equal to a positive 2 is going to be my intercept. And we do already know that we have discontinuous points at x equals minus 2 and x equals 6. They were in our domain part.
How did you get that?
Because discontinuous is at the bottom.
Yeah.
The 0 is 1.
when you look at this fraction here, the top, whatever makes the top equal to 0 is where you find your x-intercepts. Whatever makes the bottom 0, they're your discontinuous points or your vertical asymptotes. Okay, does that make sense? So that's where I'm getting those from. Table of signs. Instead of chatting, how about you start subbing some things in? So we've got the smallest x value we've found is -2, which was one of my discontinuous points. Then I had a +2, and then I had a 6. They were my 3 values that I found for x. The discontinuous points, you can just put stars in those ones now. And 2 is the 0. All right, I need to pick values in between. So let's go to -3. Between -2 and 2 is 0. Split the difference in there. Let's go to 4. And I do need one on the other side of my 6 there. Did you say 10?
8.
I did 8 because it was going up by 2s there. All right. Do I need to type them in, or can I just give you the answers for this and get through this faster? All right. -10/9, so the first one's negative. 1/3, so the next one's positive. 4 should be 1/3, and it's positive. And the last one is 3/5 positive.
Oh.
Actually, I think that might have been negative 1/3. Sorry, there's a minus sign in there. That one's a negative 1/3. Sorry, Mr. Minus sign. Okay. Number 4. The asymptotes. And that's the sad thing about these questions. You make one little mistake somewhere and it messes the whole rest of the question up.
Can you still get marks?
Oh, absolutely. If you've shown correct steps, procedure. So starting with our vertical, we have 2 of them. So let's do our when x is equal to -2. We want as x approaches -2 from the plus side and x approaches -2 from the negative side. Okay, let's look at our table of signs. -2 down here. If I look just to the right of it, that's the positive side, I'm at 1/3, which means that I'm going to be positive, so it's going to be going to positive infinity. If I go -2 again, but I go to the left side, it's negative, so it's going to be y is approaching negative infinity. Okay, next one. As x is approaching 6 was my other vertical asymptote. I want the plus side and I want the minus side. So on the positive side, it is of the 8. I have a positive value there, so that's going to be going to infinity. And at 6 on the other side, it's at negative 1/3 or negative sign, so negative infinity. Yeah, we're getting this? And now for, you're getting it, Max, even if nobody else is. You're getting it? Good. So that was for the vertical. Horizontal. To find a horizontal asymptote, first thing we should do is divide our equation through by the highest power on the denominator, which was x. Now I'm going to go all the way back to the original one. It'd be a pain to do that with brackets because then,
What if you expand it?
Yeah, that's just,
Yeah.
it's just expressions for x equals 12.
Okay. You see if you get the same thing as me. Let's go. So I'm going to divide by x into my original equation. So on the top of your page there, it's going to be f of x equals, on the top, it's 1 over, so it's going to be 1 over x, over x divided by x is 1, plus 2 divided by x. Second fraction, 1 divided by x on the top, x divided by x is 1, minus 6 divided by x. So that means as I now investigate what happens as we go to infinity or negative infinity. All right, infinity. That's equal to 0, that's equal to 0, that's equal to 0, that's equal to 0. So this first fraction is 0 over 1. And the second fraction, so 0 over 1, and the second fraction is also 0 over 1. And so that is simply equal to 0.
How do we get 0 over 1?
Because 1 over infinity is 0. Anytime you have these fractions in here, these parts are all going to be equal to 0. So that's a 0, that's a 0, so I've got 1 plus 0 is 1 on the bottom. Yeah? And this one is 0 here, and 1 minus 0, so still 1 on the bottom. Yes? Yeah. 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 Okay, then for negative infinity, is there any difference? No, it's going to be exactly the same thing. That's going to be approaching 0 as well. So I have a horizontal asymptote at y equals 0. Okay, let's draw it.
All that was just sketch a silly graph.
Okay. All right, my vertical asymptote was at -2 and at 6. Remember to label them. Oops, start that again. The horizontal asymptote is on the axes at y equals 0.
Where did you find that?
The very last thing right down the bottom. I found an intercept or a 0. Where was my 0? At x equals, it's in here, x equals 2. So there's an intercept right there. Now let's put in our little marks around our asymptote. What's wrong? Okay.
Intercept on that asymptote.
In my intercepts here in step 3, oh, I just moved it to but I didn't. I found my 0 from the numerator, whatever makes the top 0. Okay, so I found x equals 2 as my only 0 for this graph.
How can it be on that asymptote?
It's not on, oh yeah, you're right. This is what we're talking about with Ben. So I have asymptotes as I'm going out, they're what they're approaching as I go out for the sides of the graph, but it can sometimes have a section of the graph in the middle that does go through it.
What? I think that was the whole point of that. What?
Yeah, I know what you're saying. Traditionally, it has always been that way. You talk about a hyperbola, then yes, your graph is never going to go through it. This,
That's just changing the words.
a little bit. Well, these are values that they're approaching as we go out to positive and negative infinity, but it is still possible for the center part of the graph to go through there. I know it's a bit of a twist there, isn't it? Okay, anyway, vertical, going through this stuff here in the asymptotes. As x is approaching -2, y is approaching infinity on the plus side, so that's on this side. But on the negative side, it's negative infinity, down here. At the +6 asymptote, then on the plus side, we're at positive infinity. And on the negative side, we're at negative infinity again. No, we're not. Yes, we are. I thought I had that wrong for a second. Then, in the middle section of that graph, you now have enough information. It comes down, and it's going to come through there,
I told you.
and it's going to come down there.
I don't know what point of view the asymptote.
You would have to sub in values if you wanted it more accurately. You could use some of the values that we've got in our table of signs. I do know, for example, my y-intercept here from my table of signs is a third. Excellent. And I didn't determine the sign on my horizontal asymptote, but if I'm starting very low down here, it's going to have to come up and approach my asymptote on that side. And this one is going to have to come down and approach on that side.